Here's a situation in which we'd like to solve for the length of the side and the size of the angle. Now, here we weren't solving for the angle size, but we can solve for the angle size. Now, consider that we want to solve for this. Here's a situation in which we'd like to solve for the length of a side and the size of the angle. Now, here we weren't solving, in this previous problem, we weren't solving for the angle size, but we can solve for the angle size. Now, consider that we want to solve for this angle, we want to solve for that side. Now, certainly one way to solve for the side is to use the Pythagorean theorem, but let's use our trigonometry here to solve for that side and also for this angle. Let's go for the angle first. Now, I have information about the side opposite that angle and the side adjacent to that angle. And so I want a ratio that involves the opposite side and the adjacent side. That would be tangent. So the tangent then of theta is equal to the opposite side over the adjacent side, 15 over 8. Now, think about tangent as though it's just an operation, just another operation, kind of like squaring or absolute value or something like that. Now, if it is an operation, and if we think about it like that, then suppose we think about, I wonder if there's an opposite operation to tangent, like undo tangent, you see. Now, if we can do that, if we can do this opposite operation over here, we have an operation on the angle. If we can undo the operation of tangent, then we'll have simply the angle here. And then we'll have to apply that undo tangent operation on the right side as well. Well, there is an undo tangent operation, and it's called the inverse tangent, or it's called arctangent. Now, so undo tangent over here, and we're left with theta. Undo tangent over here means arctangent of 15 over 8. Now, there's another designation to this, and it is, in fact, on the calculator, we're going to look for it on the calculator, and it's the second function on tangent, and you'll see the marking on it. It has tan and then a little exponent of -1. So the inverse tangent operation is what that's all about. So we would use the calculator then to make this calculation. So we would find it to be, now let me write the steps in doing that. Here's what you do. You press second and then the tangent button. Now these two together, the second function on tangent is arctangent. Okay, a parenthesis will automatically open, and then you enter 15 divided by 8, close the parenthesis. Now the parenthesis is automatically opened on many calculators now, so I'm not opening a separate parenthesis here. It's already opened when I do this. All right, but you close it over here, and actually you don't have to close it in this particular circumstance, but it's wise to close parentheses that have been opened for you because of future kinds of more complicated problems that we'll run into. At any rate, we'll have 15 divided by 8, close parenthesis, and press enter, and we find the value here for the inverse tangent of 15/8. And it turns out to be approximately 62 degrees. So we have theta then is approximately 62 degrees. All right, now let's find x. And let's find x by using a trig ratio. Now, we have the value of theta. We know theta to be approximately 62 degrees. And I'll put that in here like this. Okay, so theta is 62 degrees. So we have the value of the angle, and now we just need to involve a trig ratio that has x in it, you see, with one of these two sides. Either one of them will work. How about the sine ratio? We have the opposite over hypotenuse. So the sine then of 62 degrees is equal to 15 over x. And now we go through the algebra of solving this for x and then use the calculator to finish off the calculation. Well, multiplying on both sides by x. On the left I would have x sine 62 degrees equals 15. This problem says the cosine of arctangent 2. Now, arctangent 2 is a request for the angle whose tangent is 2. And this is the cosine of that angle whose tangent is 2. Now, it turns out that we can make this calculation even without determining the size of the angle. You see, we can do it like this. We can say, okay, I know that the angle whose tangent is 2 is an angle in a right triangle, and I can actually compose that right triangle like this. And if I'm talking about the perspective of this angle, the angle whose tangent is 2. Now, tangent is opposite over adjacent. So all I need to do is make sure that this fraction is equal to 2. So I could make this 4 over 2, or 10 over 5, or 12 over 6. But the easy thing to do is just to make it 2 over 1. And now I can find the length of this side. And once I have the length of this side, I can find the cosine of that angle. You see, without even finding the size of the angle itself. All right, I can find the hypotenuse like this. C squared is A squared plus B squared. So C squared is 2 squared plus 1 squared. C squared then is 4 plus 1, 5. C then is plus or minus the square root of 5, and we want the positive version, so it's the square root of 5 that we're after. So the square root of 5 is the length of the hypotenuse, and now the cosine of this angle is adjacent over hypotenuse, so it's 1 over the square root of 5. So this becomes 1 over root 5. And we would probably go to the trouble of rationalizing here, but the important thing is the calculation according to this request. The request here is for the angle whose tangent is 2, and once we have established the situation on a right triangle, we can find the cosine of that angle. And we do it by finding the lengths of the sides within the right triangle rather than finding the size of the angle. Here's another one. We're going to work it the same way. We're looking for the tangent of the inverse sine of negative 3/4. Now, understand what this means. This is a request for an angle whose sine is negative 3/4. An angle whose sine is negative? Where does that angle fall? Well, we know with inverse functions that for the sine, the angle is either in the fourth quadrant or the first quadrant. And since the value is negative, we have a fourth quadrant angle. Fourth quadrant angle. We have a fourth quadrant right triangle, too. The situation looks like this. We're talking about an angle that falls in the fourth quadrant and a right triangle in the fourth quadrant. And let's see, the sine of this angle is negative 3/4. Now, negative 3/4, one of either the numerator or denominator is negative, but we know that the hypotenuse is always positive. And so in this opposite over hypotenuse idea, the hypotenuse is positive, so the opposite side is negative 3, the opposite side from the perspective of this angle. Okay, now we have two sides. We just figure the third side, and then we can calculate the tangent of the angle. All right, let's do that. We have C squared then is A squared plus B squared. The hypotenuse is 4, so this is 4 squared equals negative 3 squared plus B squared. This is 16, that's 9, so we have 16 minus 9 equals B squared. B squared then is equal to 16 minus 9 is 7, so B is equal to the square root of 7. And it's the positive square root because we want the distance along this positive x-axis, and so this is the square root of 7. Now, the tangent of this angle is, let's see, opposite over adjacent. It is negative 3 over the square root of 7. So we write negative 3 over the square root of 7, and we could rationalize from here if we want to.